So hello, everyone. My name is Andres Castañeda from Codehouse. I'm very excited to be here sharing with so many great speakers in this SUGCON 2021. Thanks for joining the session. I hope you find it interesting. And for those of you who don't know me, I've been a Sitecore developer for more than 11 years. But in the last 2 years, I've been focusing more in the cloud infrastructure and DevOps to make processes and solution implementations more efficient and smooth. Now, jumping into the topic, this session is to share what I found on my journey implementing Sitecore 10 containers deployed to the Amazon Elastic Kubernetes service. And as a bonus, I have included associating an Azure front door as being the entry point to the website. And this is only to show the possibilities of doing some cross-cloud provider implementations, even though in reality, you may end up using a solution within the same cloud provider. So I will go through all of these slides in the presentation, and in the end, I will switch to the browser to navigate on the AWS Management Console, the Azure portal as well, the Azure DevOps pipeline if I have time to do that, and I will also show something on Visual Studio Code using the Kubernetes extension. So this is to save time and avoid switching, between applications. So as part of the demo, I'll be showing the Sitecore MVP website deployed into the AWS Elastic Kubernetes service. I also thought it was important to highlight a few differences between the EKS and the Azure Kubernetes service offering. So as you know, Sitecore released the MVP website as an open source project for developers to have an idea on how to start deploying solutions to the Azure Kubernetes service with examples using the Azure DevOps pipeline and how to use the Docker Compose and the Kubernetes extension that are part of the pipelines task. It is important to highlight that the source code helps you to get started on, as I said, the Azure DevOps pipeline, so how you can build your custom solution and your Sitecore images from the Docker Compose specification, so as well as pushing the images to the container registry, and finally, how to deploy to the Sitecore solution to the Kubernetes cluster. If it is the first time for you to implement Sitecore 10 containers, it is extremely important for you to go and visit the official documentation available. It's very complete, and you try not to cut corners on that. There's very good explanation on everything. You might come across with issues that are actually mentioned on the documentation. I know that we are all on tight deadlines to deliver solutions, but remember, slow is smooth is fast. So also, I 100% recommend to go and watch the series of videos on YouTube channel about Discover Sitecore around Sitecore 10 containers. And by the way, thanks, Rob, for such a great job on those videos. So if you haven't done anything of these, please go and check it out. So first thing, what is EKS? So it stands for Elastic Kubernetes Service, and it is the Kubernetes cluster offering as a service from AWS, and is the equivalent to Azure Kubernetes Service or the Google Kubernetes Engine. And how is different from the AKS? Well, it's not much in general, since it provides the same fully featured Kubernetes cluster. However, there are a few differences I found while working with both services. And before jumping to the differences about them, I want to emphasize and encourage that for any new greenfield project or Sitecore upgrade, you recommend this to be done in containers, because all of the benefits of this that you might already know, like faster developer onboarding process, faster development in general, and most important, the very consistent deployments across your environments. And I know when you start actually working with containers. You pull your hair from time to time, but I think it pays off once you see that all of the environments are almost identical. Another thing worth to mention is this, Sitecore promotes Azure as the way to go for hosting the environment. First, because of the partnership, and is indeed the best option, I would say, in terms of cost. And I also have other opinions about that, but you will always find a customer that is married with a specific cloud provider, so you need to as well have your options on how to deploy to those cloud providers. The great thing about containers is that you can deploy, your environment to any of these cloud providers, as long as they have the Kubernetes as Kubernetes service as an offering. And by having this, you pretty much have your, I would say, maybe 70% of your infrastructure implementation. However, you will still need to understand the capabilities specific to the cloud, the specific cloud. And if you want to as well integrate with, let's say, their native load balancer, that's something as well to consider. So what are the differences? One of them is AKS, meaning Azure does not charge you for the cluster management service, but EKS does. So AWS will charge you around $70 US, while on Azure they won't charge, which is great to be honest. Azure provides newer versions of Kubernetes cluster than AWS. So this is something I found, that while on Azure the version was 1.20, on AWS they were still providing 1.18 as the latest version. But I can say that I think in the last 6 weeks, AWS started offering even up to 1.20, which so they came back on that, and so they moved really quick. But as of this week, from what I checked on Azure, they are actually offering 1.21 in preview version. So they are still ahead most of the time. So that's something if you really care about. Azure provides integrated preview of the Kubernetes cluster workloads with better visibility in the AWS version of it. So yeah, comparing both, I could tell that actually Azure was giving me more details, and there's even ways that you can edit some configuration directly there. I mean, it's maybe not recommended, but that's something that gives you more. AWS Cloud Native Load Balancer has simpler implementation with Kubernetes Ingress controller and get provisioned really fast. So this is a good one for AWS. Their application load balancer, which compares to the application gateway, is faster to get provisioned by the Ingress controller. In case of Azure, the application gateway has to be separately from the creation and the Ingress controller, but you have to have, you need to have this created in advance before applying your Ingress. One thing, in AWS, only Linux node groups are fully managed on auto-scaling, and for Windows node groups, they are self-managed. On Azure, the implementation of auto-scale comes out of the box, and this is for obvious reasons. Yeah. And in EKS, the support on Windows containers requires you to install a VPC admin controller webhook to accept node groups of Windows. And this one is not a major thing, but it's something additional to do. And we will talk about that later in the presentation. And so what tools you will be using for provisioning? And so what are your options? Use the EKS COTL, or sometimes I just say EKS CTL for the provisioning. So this tool, this is a very popular command line tool that allows you to provision very easy and manage parts of the configuration of your EKS cluster. And behind the scenes, and based on the parameters provided, there's a CloudFormation stack that gets created to build the environment. And if you ever need to delete the environment, that basically that CloudFormation gets called for deletion. I highly recommend that you always go and check the latest version of the EKS COTL. The documentation on AWS many times refer to a specific version to support a feature of this tool. And they actually release quite often new versions on the EKS COTL. And for those who are not familiar on CloudFormation, it is the equivalent to ARM templates in Azure. Both allows you to manage and deploy infrastructure resources on the respective cloud. So once you finish provisioning the EKS COTL, you can go ahead to the AWS console, management console, and check the CloudFormation so you can have an idea what resources get created, because there are many things that happen there. And how you can install the EKS COTL? Well, with Chocolately, and it's very easy. And there's the command you would use. Okay, so what's the first thing you need? So you're going to be using a user to provision the EKS cluster, and this must have a minimum of IAM policies that you can find on this link. One thing to be aware is that the user which creates the cluster is the only one that can see in the AWS management console the details of the EKS. Other users have to be set up with specific policies in order to be able to see them. To be honest, I have tried to do this, but I don't know, for some reason I just couldn't. So if you ever accomplish that, just let me know. So you may also have to review the policies depending on how restrictive you want the permissions to be, or your AWS account administrator, especially around the last one, which is the IAM limited access. So one thing that I can say that if you decide to change the permissions, the only thing that I can say is good luck with that, because it's not fun and easy to be debugging permissions on AWS. So what else do you need? One thing is be sure to define the permissions for the node group before provisioning them. These IAM roles are associated to the nodes when they are launched. By the way, node groups in AWS are the equivalent to node pools in case of the Azure Kubernetes service, and they are basically a virtual machine scale set in the in Azure, and in AWS they are called auto-scaling groups. And in order to allow the Ingress controller to create the application load balancer, remember that you need to have the last two policies from the image, the Elastic load balancing full access and the AWS load balancer controller IAM policy. So how do I start creating a cluster with Windows node groups? So there are two ways you can provision the cluster in general. So I recommend first create the cluster without associating any node group, and then separately create each node group, the Linux and the Windows. As you know, you must have at least one Linux node group. This is also known as node pooling in Azure, as I said. This is a minimum requirement in EKS and AKS. We know that we're going to be deploying an Ingress controller, which most of the time, if not always, is based on a Linux node. So apart from the system, you need to have it for the Ingress. And when creating the node, I also recommend that you use the YAML file approach instead of the parameters, and because it is easier to read and maintain. And you can see the YAML example in the right image. And notice how one thing that you need to notice is the Linux and the Windows node group YAML configuration. They will have a difference in the main property that is used. And the Linux uses the managed node groups because, as I mentioned before, the Linux are only fully supported managed node groups in the EKS cluster, and the windows are self-managed. Okay, and here in the image, you can see the output of the cluster creation without any node groups, and just the EKS provisioning takes around, what is it, like 12 minutes? So, and then the next thing is, so to allow the Kubernetes cluster to integrate with IAM services, you have to enable the OpenID Connect provider on the EKS. That's what you see in the command in bullet 3. And then you need to install what I mentioned about to support Windows, the VPC admission controller webhook to accept the Windows node group to be registered, and that's what you see in the bullet 4. And one thing that I should mention is, I don't know if it was because of the version of EKS I was running at that time, but I have issues running the command of EKS Cotl, and I ended up using the PowerShell script, which, I mean, worked very well. And this is the output of the creation of the Linux node group with the VPC. The white lines are the VPC controller webhook installation. And because my provisioning was for a demo, I only have one node in the Linux node group, and it took around 4 minutes to create it. So next slide. So, and we go to the main part of provisioning the Windows node group. Once you confirm the VPC admission controller is running, then provision the Windows node group, because otherwise you will get an error. One recommendation that I do when provisioning the node groups is to set the private networking true to provision them on the private subnets. And this is to avoid the worker nodes to get public IP and prevent anyone to target the nodes for whatever reason. When you actually create using the EKS Cotl, by default, it will create subnets, a set of subnets meant for public access, and then one for private. So that's something, reason why I mentioned this. And you might be wondering what's the difference between the private networking or not. If you decide to set them as true, the private networking, the pods will access internet via a NAT gateway. And yeah, so all of the services and pods running will be doing that way. And as I mentioned, the nodes won't get a public IP. But if you do set it to false, so that means they will create it on a public subnet, and then they will be using an internet gateway, and the worker nodes will have a public IP. So if you are concerned about your worker nodes having public IPs, then, as I said, I recommend you set the private networking to true. You might be wondering, can I use, well, actually, sorry. So this is the output of the creation of the Windows node group. It took around 12 minutes because it is based on two instances on that node group. And so the next thing is about if you can use Terraform, absolutely, but bear in mind that you will need to define every single resource that is part of the EKS cluster. And if you are proficient on, how all of the resources or how Kubernetes works or how to do the implementation, let's say by hand, then go ahead. Or you could also, I would say, go and check the resources created on the CloudFormation and then apply the same things by yourself on the Terraform. It will give you, maybe more control in applying your changes because of the Terraform plan and all of those great things. But from what I can say is EKS is concise and is very easy to use. You can as well use it for production environments, but you will need to find the additional parameters to set everything as much as possible for a production level environment. So we get to the point of so at this point we have our Elastic Kubernetes service ready to receive our deployment. Now we're going to create the application load balancer ingress controller. So Sitecore by default provides the nginx ingress controller to allow us access to the relevant Sitecore services as a single entry point to them. It does reverse proxy, SSL termination or offloading with the backend services. And using the nginx as ingress is the most straightforward way to expose the Kubernetes services on any cloud provider. And nevertheless, in both AWS and Azure for the respective Kubernetes service, they provide a cloud-native integration with their load balancers. Once having the ingress controller, you will only apply the ingress configuration with the relevant annotations. And so these integrations are meant to work best together, or simply because they are more robust in many of the features they provide. And by the way, if you have to provision an ingress controller, that means you are familiar with Helm charts, because that's the way the nginx ingress controller, like from the MVP website, and you will also find that on the Sitecore official documentation on those PDFs. And if you don't know what is Helm, Helm is the Kubernetes package manager that helps you install application that comes into play on your entire architecture, but you don't directly support or maintain them. And Helm, doing this through a Helm chart, it will allow you to do like upgrades, rollbacks if necessary. So you can go ahead to the official website and read more about Helm. Here we have a very simple diagram of the ingress controller. This is, of course, a non-production environment, since we are using the same application load balancers for the CM and the CD services. In a real-world scenario, you will have separate ingress for the private services like CM and ID, the identity server, and even CD if you are using JSS, and then an ingress for the public, which can be a CD. In there, you can have the CD if you are using traditional MVC, or just a headless app if you are rendering your website in this way. The application load balancer is provisioned by the ingress controller as it detects an ingress being created. In the image, I also put some of the like the host names that I will be using for the demo. So how to deploy the application load balancer ingress controller using the Helm chart? The first thing is to register the AWS EKS chart as a Helm repository. And you have to also apply the CRDS, which stands for Custom Resource Definitions, which are basically like way to define data structures on Kubernetes. Then you can use the last command to install the AWS load balancer controller by passing the namespace of where you want to put the ingress controller and the cluster name, of course. And if the permissions are set up correctly to manage and create the Elastic load balancer, then the ingress controller will be created. The ingress controller in both AWS and Azure are deployed in a Linux node, so that's something to just be aware of. And in the right image, you can see how the ALB controller pods are created. Those are the last two in the image. Okay, now let's go into the gotchas, or things that you need to be aware of. You need to be aware of when deploying to the Elastic Kubernetes service. So you might be facing that you cannot create Windows node groups. So you may have jumped immediately and tried to create a EKS cluster, defining the node groups of the Linux and Windows. But if you didn't create the VPC admission controller webhook, then it will result in an error. That's the very first thing if you find this situation. Another one is AWS the load balancer not provisioned by the Ingress controller. For this issue, as I mentioned on slide 9, the policies that you need to have there, they need to be for the defined for the Linux node group. And yeah, other thing that you can do if, let's say, it's not about permissions, is that you can go ahead and do a kubectl describe, then the pod, which is the AWS load balancer controller, and you may find errors there. You may also find that you are unable to create more pods on a worker node. And so this one is very interesting because so every time you create a pod in a worker node, it will get associated an IP from the worker node. Well, let me just say that. So a worker node is basically an EC2 instance, or in the world of Azure, a virtual machine, because it's powering the pod is where it's running. So there's a network adapter for the EC2 instance. And if you look at the documentation of AWS, there are limitations of the number of IPs a network adapter can have. For in the case of Windows, a Windows is it can only use the first elastic network interface, and it cannot use 3 or 4. Even in the documentation, it says you can have 3 or 4. You can only have 1 when it is being used in a Elastic Kubernetes service. So, for example, I'm gonna say that if you have an M5 2x large instance, so for that you have 15 IPs per network interface. So even though you can have, as I said, like 4 interfaces that you can have for that machine, it will only be using one, the first one, and it will also take 1 IP for the system, so you end up having only 14 IPs. So we end up with the formula that you see here, that the maximum number of pods that can be created are the number of IPs per ENI minus 1. So while this might not be an issue for a production environment because you will be having multiple worker nodes, for a non-production environment and to reduce cost, you may not want to have many EC2 instances running. So this can be a problem because you will try to get as many pods in less number of worker nodes. So just consider that. In AWS Kubernetes service, you need to provision at least 1 Linux node group to support the system services, which adds an extra cost to your environment. So that's as I said, is another thing to consider, is that, another thing to consider is that during a deployment, ideally you have available the same number of pods to be created on that node if you're going to be doing a deployment, even though there are rolling update strategies that you can do to say, like, I want to have up to 1 pod being created and I don't want to have pods being unhealthy during the deployment. So it's good to have a good number of available IPs to have pods in the node. One thing that I faced is, especially with the MVP website, was that pods were resolving externally instead of internally. And so what happened is the CM hostname for some reason was, if I actually went to a tool called MX Tools. If you just put their CM, it will give you a public IP. And when I was going to the pod, I was getting that IP as being to be resolved on that pod. So what I had to do to work around this was to edit the config map for the core DNS, and the command here that you see in the left part, the first one, it will by default will open your Notepad editor. You will change the contents by creating the rewrite rule that you see on the image. Once you close it, you save it, you close it, it will push the changes to the Kubernetes. And then after you do that, in order for the pods to pick up the change, you need to restart the core DNS service by executing the last command. And that will roll out a deployment in the core DNS. And once you do that, it will take effect on the pod within minutes. So other issues you may find is that the AWS Ingress controller the AWS Ingress controller created on a Windows node. So it has happened to me that the Kubernetes schedules the AWS Ingress controller to be in a Windows. So this, as I said, it has to be a Linux node for the Ingress controller. And so one thing that you can do if you are struggling to fixing this by associating a node selector on the, let's say, nginx Ingress controller, or in the case of AWS, the best thing you can do is do a taint, execute the taint command. The taint command will stop or exclude nodes for getting pods for creation. So the way is like, whenever you apply a change, it will create a pod in whatever worker node is available, and it will schedule it. And so you don't want to, you want to exclude your Windows from receiving pods, and it will force to be created on the Linux. And the last issue I faced was the auto-discover subnets unauthorized operation. The way that EKS cluster resources are linked between them or are help to apply specific actions on the configuration is by having tags associated to the resources in AWS. So the first thing you need to do is go and check that you have the tags in those resources, in this case, the VPC subnets. Once you check that, if they are there, then the second thing is check permissions, the IAM policies, to see that everything is fine. All right, cool. So we are getting closer, deploying the Ingress. The Ingress specification should contain the following annotations to be picked up by the Ingress controller and do the necessary changes on the application load balancer to match what is desired. The first two annotations you see are the class and the scheme. The class value is ALB, but it could, because application load balancer, but you can also have NLB, which stands for network load balancer, and this is a layer 4 type of load balancer, which in this case we will never use because of the way we need the SSL offloading and all of that. So, but that's an option you have to create an NLB. The scheme is internet facing because you indeed want to have access from the outside on the application load balancer, but you have also the option of setting as internal. Internal will be the case that you use when for the, let's say, for the CM and the ID services. And you will also be using, if you set up a site-to-site VPN with the environment, so you will be connecting privately. And so, but if you, let's say you don't set up a site-to-site VPN with the environment and you are okay accessing it publicly, then the thing that you will be doing is provide IP whitelisting, and you will be using the annotation of inbound CIDRs to do that. And in the part of the SSL configuration, in the SSL configuration, we have annotations for the SSL redirect. So what I'm doing is a redirect for whatever incoming request on the port 80 to make a redirect to 443, which is the HTTPS. And I also have the certificate. So I upload a certificate in the AWS certificate manager, and you only provide the ARM to the certificate, and it will be attached to your Ingress. And as I said in the last point, is if you want to restrict access publicly, you will be including CIDRs on that annotation in a comma separated. And okay, so check how the one of the things that you will see on the on the left image is the HTTP redirect needs to come first in the rules on the Ingress. And one thing that you will notice is the way the application load balancer works is once you apply a change in your Ingress, well, you will have, you will have hosts, and those hosts will become target node groups in resources in AWS, which emulate to your service. And then within those target groups, you will have IPs, and those IPs will be the IPs of the pods behind that service. So we're getting to the pointing the Azure front door to the AWS application load balancer. So for those of you who don't know about Azure Front Door, so Azure Front Door is a global scalable entry point that uses the Microsoft Global Edge Network to create fast, secure, and widely scalable web application. It features web application firewall and CDN. So one thing that I will encourage everyone is to have a WAF for any site that you implement. And in the case of let's say Azure Front Door, or if you are using application gateway, to attach the WAF, set it on prevention mode. Don't leave the default. Sometimes the default, I think, is detection, which will only log, make some logging about what could be blocked or not. So this will add extra security to your website. And okay, so let's jump into the demo. So I will be going through the application Azure Front Door configuration, then the AWS Management Console to see the application load balancer and the EKS elements. Then jump into Visual Studio to explore in the Kubernetes cluster from the using the extension. And then finally, if we have time, see the build and deploy pipeline. So I'll be switching. Okay. All right. So here is my resource. I created this front door. This is the name. And then you will go to the front door designer. In the front door, once you get to configure the front door, you will find a lot of similarities of application gateway, how you configure an application gateway. But if you have also configured an Azure CDN, you will see also features being combined here. So you have a front door, a front end. And by default, you need to create one front end, and you will get associated an Azure FD.NET domain. So this one, I didn't change anything. Just the default. And I associated a WAF. I will touch on that later. And the main part comes into the backend, which is where your services are living. So what I added as backend hostname is, so I created a DNS record that is pointing to the AWS application load balancer. This is, let's say, like a fancy DNS record. I could have put here the whole DNS name on that you find on AWS, but I created this record here. But one important thing here is this is only to look up for the IP of the load balancer, but you need to set the backend host header of what is the host name of your actual website within the application load balancer. In this case, I added virtual SUGCON 2021. I just left the others as default, and you also have the option to set a weight on the traffic. If you want to have multiple backends, you can split traffic. And as you can see, I decided to go to custom host, but these are, the integrated options you have within Azure. So, and just touching on the rules, I have a default rule that it's set up to accept only HTTPS requests. I selected my two front ends. The first one is, let's say, like my default front end, but then I created a custom domain for the front door. And what I'm setting here is the pattern to match is going to be everything on the website. And the rest are basically, so the backend pool, I selected that, HTTPS, and I don't want URL rewrite or caching. And just to mention real quick, I as well have here, let's say, like a rewrite rule or redirect on if anything coming on HTTP only, it will get redirected to the protocol HTTPS. It will do the redirect as 302, and I will preserve, the host name, path, and query string. And one thing, if you go to this URL, you will get your website, but of course you won't be using that for your website. You want the real domain, so the real host name. So you can create your custom domains here. You can say like, I'm using the plus option here, and you will define here something, and you can say, yeah, I want. Okay, I will skip that, but I decided to go for the certificate management type to be front door managed, but you can also use your own certificate. I think if you select this one, you will get the option to pull from Key Vault. And the rest is, as I said, I defined it web application firewall. And yeah, so I'm gonna switch real quick to show how I have so this is my DNS zone. I have created all of these records in my DNS zone. So I have here, you will see here, the virtual SUGCON, the main one is pointing to the front door. But for the ID and the CM, I'm pointing them directly to the DNS of the load balancer in AWS, so they don't go through the front door. Yeah, and let me just show you real quick the website. So yeah, here it is. If you go to this website, it will load the MVP website. I added a SUGCON 2022 branded background. And you can also go to the azurefd.net domain. And yeah, so I'll be, by the way, this is for the presenters, if I'm running out of time, feel free to interrupt me. And if there are questions, maybe start preparing them and maybe make room for that if there are. So jumping to the AWS.
We have around 2-3 minutes left.
Okay.
So if you can,
speed up. Yeah. All right, cool. Yeah. So this is how you see the application load balancer in AWS. If you go to the listeners, you will see that you have by default like 80 and 443. If you expand on the rules, you will see the host set of rules. They will be matching the ingress you applied. So we have the host name, apply the path, and here you can find the target groups that you have for that. And this tab shows all of the target groups that were created. As I said, this is all managed and created automatically by the Ingress controller. So any change you apply on Kubernetes, it will look for, okay, there's something I changed, I will apply the necessary resource, creation of target groups. Let's say if I go to the CM, you will see that the IP is this one. And if you actually go and say like kubectl describe pod of the CM, you will get this IP as being the private. So that's how you have it. And jumping to the EKS cluster, so you will be searching for container services. I have here my clusters. This is the only one, the one for SUGCON. And here I have my 3 nodes, the Linux one, and then 2 for the Windows. If I go to the workloads, it's very similar to what you will see on Azure, where you have your namespaces. I have created one for SUGCON. Everything related to the Sitecore things are here. And if I jump into the configuration, if I go to, let's say for the networking, the way that it was created is, and I mentioned about this, is 3 public subnets, 3 private subnets, and whatever worker nodes you have there that are linked to this cluster will be able to, see them. And what else? Oh yeah, I wanted to show about the cloud formation. So as I mentioned about the EKS COTL, it will create stacks of cloud formation. The first one is the one about just the EKS cluster creation. If you, let's say, go into the details here, it will show you all of the events that happen during creation. Here you will see all of the resources that were created. For example, the control plane, it created the internet gateway, the NAT gateway, and you'll also create some public route tables. This gets to more into the details of the infrastructure behind the EKS cluster. You have also the subnets and so on. I will just pull real quick as I'm running out of time. Visual Studio Code. I have, if you go to the Kubernetes, I already have registered in my kubeconfig. I have the connection to my EKS cluster. And if I expand on my namespaces, by the way, this is a great tool if you are not very command line, developer who knows every single command of kubectl, get me this or apply this, whatever. This is very handy. So you can go into here, expand the nodes. I have here my 3 nodes, as you could see on the management console. I can see my pods were they were created, and one thing. Let's say if I want to go to the network, if you go to the Ingress, if I do, you can do right click and then describe. It will get you the details of how you got configure your Ingress component. So, and by the way, it also shows you what Helm releases you have. So if you expand here, let me actually try to see if, so you will see the AWS load balancer Helm there. And I know that I'm running out of time, so I'll just jump to my pipelines. I'm gonna go very quickly on this. So I had a build pipeline. It has two tasks, basically very, very small. One for building the images taken from the Docker Compose files, and then I push the images to the registry. So, and the other important part is how I deploy everything. So I have from the MVP website example of the Azure Pipelines. What I did was all of the tasks that you see there on the single file, I broke them down into stages so I could control what I wanted to deploy. So let me, for example, open this one. I have a stage for generating the artifacts. I have one for example, this is the one for create the Ingress controller. I have a set of default, let's say, tasks that will execute for each stage, but the main one is the Helm installer. I need to install first Helm in the agent in Azure, and then create the AWS ALB. And if I just want to go real quick to that is, so I also did some changes on, I created templates on my Azure DevOps pipelines because I wanted to, so basically I have a single type of, let's say, I have a template where I just say stage deploy. I have what type of Ingress controller I want to provision. So I added some if statements on the templates to say, okay, if it's an ALB, it's gonna be then the task that it will be on the stage or loaded is gonna be the one for ALB, but I could also have nginx. I also set the cloud provider if I want to have AWS or Azure in this case. So for example, if I go here in my template, I have my options of cloud providers are Azure and AWS. I have some if statements here saying that if it is of type Azure, then go through this template, otherwise go to this EKS. And yeah, if I go to the EKS, I have more stuff here.
Rasmus, you are muted. Let me unmute you.
Oh, sorry. Yeah. Thank you for the presentation, Andres. Yeah. Do we have any question coming in, Thomas?
Yes, there are two, but as we are out of time a bit, let's read one. I just read the first one. Yep, great presentation. Really interesting how you can use as Azure front door with the AWS Kubernetes cluster. Is the AWS equivalent to front door, cloud front, or is it global accelerator?
Well, I'm not aware exactly of a matching service on AWS. In Azure Front Door, one of the main reasons you will also be using it is because of the WAF, and I know you can use in AWS the web ACL to have WAF associated to your application load balancer. But as of now, I don't know about other service equivalent to front door. In case of cloud, CDN is CloudFront is the one on AWS. Yeah.
Okay, great. Thank you very much for the presentation. It was really great.
Yeah, thank you. Thank you for having me, and have a great weekend all.
Yeah, you too.
Okay,
you too.
Thank you.
Bye-bye.
Bye.
Bye.
Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.